Silas,
Hi,
how are you doing this week?
you doing alright?
Good. So I've got your teacher's website up here. You still on
Okay.
chapter 6?
Yeah.
Which one? Which section?
4.
Oops. PowerPoint presentations. Boy, that seems to be the way everybody's going. We've got more than just your teacher that puts everything in a PowerPoint presentation. Okay. Do you have some problems that aren't on here?
Yeah, we did all those in class.
Okay.
And then homework is like factoring cubes and everything.
Okay. Do you have some?
Yeah, first one's x cubed plus 64.
How's that factor? Factors into a linear factor and a quadratic factor.
Yeah, I'm just looking at.
Always make the linear factor be the same sign.
Be x plus
The cube root of 64.
yeah.
In other words, because this is the sum of cubes, then our linear factor is the cube root of that plus the cube root of that. Then our quadratic factor is x squared, opposite sign of whatever this sign is, we're going to make it opposite, and it's the number times the variable, so 4x plus this squared. Okay, so there's a pattern there. So let me give you another problem. Factor that for
me. 3x plus 2. And then 3x squared.
Which is 9x squared.
9x squared.
In other words, it's quantity 3x squared.
Okay. And minus 6x plus 4.
That's exactly right. And if it was 27x cubed minus 8, the difference of cubes, the only difference is this becomes 3x minus 2, same sign for the linear factor. Quadratic factor, opposite sign in the middle. Everything else is exactly the same, including the plus 4. In other words, the only sign that changes in the quadratic factor is the middle term. So these two are what you want to know. But they're actually they're not that hard. It's a cubed plus b cubed equals a plus b times what?
Times a squared plus b squared?
No, it's a squared minus, for the middle term, opposite sign, ab plus b squared. So this is the general formula. And then let's write the general formula for the difference of perfect cubes. What would this be? In other words, if you know the first one, you can figure out the second one. What is this one?
A minus b.
Correct.
And then squared plus AB minus B squared.
Plus b
Yeah.
squared. Both of them are plus b squared. Because notice that when you multiply that, you get a minus b cubed. In both, in other words, up here you're going to get a plus b cubed when you multiply that b times the b squared, and down here you're going to get a minus b cubed when you multiply that minus b times the b squared. But notice the similarity here. In other words, for the linear factor, use the same sign. For the middle term, use the opposite sign. And that's pretty much it. And that'll give you a way to memorize both of those. Math is frequently just figuring out a trick for memorizing stuff. I mean, memorizing stuff really is an art form. I used to play a lot of gin rummy. I was really good. And having to memorize the cards that have been played, there is a certain mechanism you're supposed to use to memorize stuff. What you're supposed to do is associate it with ridiculous images or something like that. You know, if I was trying to remember the Queen of Hearts had been played, I thought of Alice in Wonderland's Queen of Hearts. And that was the image I thought of, and that helped. You know, so there's lots of tricks for memorizing stuff. And to be good at math, you have to be able to memorize. You really have to be able to. That's probably the most important skill to being good at math, is being able to memorize stuff. All right, what other problems do you have?
This one you actually have to solve. It'd be x cubed plus 64 equals 0.
Okay, factor this.
X plus 4
times
x squared minus 4x plus 16.
Okay, now solve this.
X equals negative 4.
That's one solution, and this will never factor normally. So don't spend any time at all trying to factor that. In other words, trying to find factors of 16 that add to 4. You're not ever going to be able to do it. This is always a quadratic that needs the quadratic formula to solve. So what's the rest of the solution? In other words, the rest of the solution is x squared minus 4x plus 16 equals 0, right?
Yeah.
Because either that's equal to 0 or that's equal to 0. So let's solve this. How do we solve that? Knowing that it can't be factored.
Quadratic equation.
Okay.
Got x equals 4 plus or minus negative 12, or the square root of negative 12 all over 2.
Where are you getting negative 12? Oh, you've already squared 4.
Minus 16.
Minus 4ac looks like it would be minus 64. Right? In other words, this is b squared minus 4ac. B squared is 16 minus 4 times 1 times 16. All divided by 2a. A being 1. Okay, now simplify.
Plus or minus negative 48.
Okay. And what is the root negative 48 equal to?
The
Look for factors of 48, one of which is a perfect square.
Be 3 root 2.
Uh-huh. No.
No.
What are your two factors?
2 and 24.
None of those is a perfect square. Find factors of 48, at least one of which is a perfect square. In other words, the numbers 4, 9, 16, 25. Those are the perfect square numbers.
4 and 12.
Okay, that's a good start. It's not going to be the final answer, but you don't have to get the final answer in the first start. So this becomes I, this becomes 2, and root 12, how can I split it up?
3 and 4.
Root 4 times root 3. So the root 4 becomes another 2, so what's my final answer?
I 2 root 3.
Well, you got this 2, and you got this 2 multiplied together. That's equal to 4.
Okay.
So I 4 root 3. So we whittle it down piece by piece. Now let's just take a second to look at that. Was there an easier way to do it? Yeah, 16 is a factor of 48. In other words, I could say 16 times root 3, and that actually saves me a complete step because I can go immediately to this step when I do that. But it's okay. You don't have to find the maximum factor that's a perfect square. It'll just take another step to do it. But that's okay. No problem with that. So in place of the negative root 48, I'm going to write 4 root 3I. Now simplify that further.
Um, 2 plus or minus 2 root 3 over 2.
No? Just,
No.
in other words, this 4 and the 2 become 2. Just like this 4 and that 2 became 2.
Mm-hmm.
In other words, I'm splitting it up into two fractions, essentially. What I'm doing is I'm saying that this whole thing is equal to 4 over 2 plus or minus 4 over 2 root 3I. I split it up into two fractions like this. And then I simplify. That becomes 2 plus or minus 2 root 3I. And there's your answer. Actually, that's the other two solutions. We had one solution, x equals minus 4. So there's 3 solutions, which you expect when you have a cubic. In other words, that's a cubic. X cubed plus 64 equals 0 is a cubic. We expect 3 solutions. We got one real solution, x equal minus 4, and we got 2 complex solutions. The 2 plus that and the 2 minus that. And complex solutions always come in pairs. If I told you that one solution to that equation was 2 plus 2 root 3I, then you could tell me automatically that another solution is 2 minus 2 root 3I. Always. If one solution to an equation is I, the other solution is minus I. Imaginary always comes in pairs. Conjugate, basically. Okay, what else you got?
2x cubed plus 2 equals 0.
Okay. This one we could solve it using sum of cubes. What would we do first? Because this is not a perfect cube. That's not a perfect cube. That isn't a perfect cube. So what could I do to simplify it to make it sum of cubes? How about we divide both sides of the equation by 2?
Okay.
What's left? What's the next line if I do that?
X cubed equals 0.
X cubed plus 1 equals 0. Right? In other words, all I did was divide both sides by 2. Now, notice we have the sum of perfect cubes. So we can factor this. There's actually 2 ways to do this problem. Let's do it both ways. So what's the factor? Since you're on the section of factoring cubics, let's do it that way. What's the linear factor? Well, x plus 1 is the linear factor. What's the quadratic factor?
X squared plus x.
Minus, the middle term's always opposite this term.
Minus x plus 1.
Okay. So one solution is linear solution.
-1.
And the other solution is, let's use the quadratic.
X.
Actually 1.
1.
In other words, it's the coefficient of x that we care about, not the x, but the coefficient. So minus b is plus 1.
So it'd be 1 squared, so 1. Minus 4. All over 2.
Okay, let's simplify that. Break that into 2 answers for me. And put it in A plus BI format.
Would it be x equals 0.5 plus or minus I root 3?
Is that the customary way they do it in your class?
That's how I put it, just so it doesn't get under the...
Okay, I don't have any problem with that at all, but there is a 2 under that.
No.
In other words, I had to split it into 2 fractions. That fraction was the 0.5, and I really prefer saying 1/2. In other words, why mix decimals in with fractions? And now it's plus or minus. I root 3 is correct, but this part of the fraction is I root 3 over 2. You cannot drop that 2. Okay? And now it actually makes more sense to say plus the real part is that, the imaginary part is that, and the second solution is this. You see why I want to put that root 3 with the 2? Because that's the real coefficient of I. If I write I root 3 over 2, it's not quite as... In other words, we usually want to put a numerical coefficient in front of the thing. When I say standard format is A plus BI, this is A plus BI. Whereas if I said 1/2 minus I root 3 over 2, That's really not a plus bi.
Mm-hmm.
Okay. So even though that there's danger of having it be interpreted as being under the radical sign, still standard format is a plus bi. There's no getting around it. So we need to put that coefficient in front of the I.
Mm-hmm.
Just to leave enough space that nobody's going to... Most of the times people aren't going to misinterpret that anyway, because how often do you get radical of I? I mean, never.
Mm-hmm.
So anybody reading that is not going to put that I under the radical sign. Okay, you got another one? You seem to understand this stuff. You actually seem to understand this stuff pretty good. You agree?
Sort of.
Really? Because, I mean, you've been able to do all of these. You want me to make one up? I mean, I don't know. Are you doing these because you've done them before our session? Or are you figuring?
This is what we did today in class.
Okay. How about I make one up?
Okay.
Actually, the one that I made up, you did perfectly. That's why it seemed to me that you understood it.
The one I just did, my final answers were x equals -1/2 and x equals 1. I got two real solutions.
Right, but let's go back and do it a different way.
Okay. It was,
How about if I go from this step, and instead of using sum of cubes, I make x cubed equal -1. Now, looks like there's only one solution. That's because the imaginary solutions get hidden when you solve it that way. In other words, -1 times -1 times -1 is equal to -1. So the solution to that is, that's definitely one of them, but it omits the complex solutions.
okay.
The way to get the complex solutions is to factor this as sum of cubes like we did, and then solve it using the quadratic formula. And when we solved it using the quadratic formula, we got 3 solutions, which we're supposed to have. Here's one of them. Here's the real one. But the other 2, that one and 1/2 minus root 3 over 2i. Unless I did my math wrong. And I don't think I did, because usually when you do sum of cubes, the other 2 solutions are going to be imaginary. They're not going to be real. If they were real, we would have derived it from that step right there. In other words, the only real solution we can come up with from solving it in the normal algebraic way is x equal -1, because that is the only real solution. But there are 2 imaginary solutions, and the only way we can get both of those is to factor this as sum of cubes like we did the first time. All right, let me give you another one. Let me make one up.
What about when they are set not equal to 0?
Give me an example.
-2x to the 4th plus 46x squared equals -100.
Notice that we're going to look for 4 solutions here.
Okay.
Okay? So, what's the first thing I can do to simplify this a little bit?
Should we get the 100 on the other side?
Well, that's one thing. Okay. That's step 1. What's step 2 to simplify it? Well, Let's take out any greatest common factors that we have.
2.
Minus 2.
Minus 2.
So I'm going to divide every term in the equation by minus 2. It's going to leave this. Now that's a lot easier to factor. However, it does point up a method of factoring that I'm not sure you and I have talked about. I think we maybe did a little bit the other day. How do I factor this?
X squared. Let's see. Minus 25 and plus 2.
Very good. So my solutions are? So if x squared equals 25, in other words, setting that to 0, what's x equal to?
5.
No?
Plus or minus 5?
Uh-huh. And if x squared plus 2 equals 0, then x squared equals minus 2, and what's x equal to?
I root 2.
Plus or minus?
Plus or minus?
Root 2I. So there's my 4 solutions. I got plus or minus 5 and plus or minus root 2I. 2 real and 2 complex.
Okay.
And always look for the number of solutions that you're looking for. Because if you do that, you won't make the mistake of omitting a plus or minus sign. In other words, if you forgot to put that one on there, it would look like we only had 3 solutions. We got plus or minus 5 and we got root 2I. But root 2I doesn't look right because imaginary solutions always come in pairs. So if that is one solution, there has to be another solution minus root 2I. And if we would have remembered to put the plus or minus on it, we would have had both of them. Okay? So when you're solving a quartic, look for 4 solutions. You will always find them. Now, the reason you were able to do this so easily is because you used a method called substitution, but you did it in your head. You let u equal x squared, and this equation became u minus 25 times u plus 2. You solve for u. Are you familiar with using substitution for doing this stuff? Have they used that term with you?
Not for this.
No? All right. Well, they may or they may not. Some curriculums talk about using substitution to turn a quartic into a quadratic. Because what that really is a quadratic in disguise, is what I like to call it. And I would love to talk more about it, but unfortunately I have an 8 to 9 o'clock session that I got to go for.
Okay.
Okay? So I will talk to you tomorrow night at 7:30? No, 8. Tomorrow night at 8.
Okay.
All right? All right, Silas. Have a good night.